to all joining us today. My name is Adele Kroch and I'm from Food Focus. And I want to thank the Dairy Standard Agency for sponsoring this webinar. We are receiving a lot of positive feedback from the industry that the webinars that we've had up to now are adding a lot of value to them, and it's great being part of it. The webinar will be recorded and the slides will also be available with the recording that you will find on the Food Focus website, and you will then have the recording as well as a PDF of the presentation today. The DSA is surely achieving their objective to support and interact with the industry, and all of this to promote the improvement of quality of milk and other dairy products in the interest of the consumer. We have a very interesting topic today, and our topic today is design criteria and factors important for effective cleaning in place, also known as CIP. Hygienic design principles relating to equipment as well as the relevant processes are applied in food and beverage operations. This is done to allow for effective and efficient cleaning and disinfection regimes in order to minimize cross-contamination risks and manage food safety risks. During our discussion today, design criteria and factors affecting the application of validated cleaning and disinfection regimes, which belongs to prerequisite programs, will be explored. What are the factors to consider during validations, qualification and validation plans, and optimization techniques? So to take you through this very interesting topic and to present it to you, it gives me great pleasure to introduce you to your two speakers today, and that is Piet Grobler and Peter Mukwebu. So I'm just going to give a short introduction to both of them. Peter Grobler is a qualified chemist with 36 years of experience in providing hygiene and food safety solutions to the food and beverage industry. He closely collaborates with various stakeholders, so from farm to fork, in the food and beverage industry on aspects pertaining to food safety. He also has application chemistry and validations in the dairy industry, drafting of national standards in the chemistry and hygiene and food safety. And he is also with EHED. He's the chair regional section of South Africa and chair working group for the red meat further processing OFT group. Peter, on the other hand, is a lecturer in the Department of Consumer and Food Science at the University of Pretoria, and he teaches modules including product development and quality management systems, meat science, and dairy technology. He's got a he's also a food science PhD candidate at the University of Pretoria, and he holds a Master of Science degree in food nutrition and culinary science from Clemson University in South Carolina. He's a professional member of several local and international organizations. So we are really looking forward to you, Piet and Peter, presenting to us today. And I'm going to hand over now to Piet. Thank you so much, Piet, so that you can present with Peter. Thank you so much.
Thank you for the introductions, Adele. I trust my slide is visible.
Yes, thank you, Piet. Thanks, Peter.
Yeah, so just on behalf of EHEDS, the European Hygienic Engineering Design Group in South Africa, I want to thank the Dairy Standards Agency for this opportunity. I think, Adele, you actually hit the nail on the head in the sense is that from a collaboration perspective, it is really all stakeholders' goal and endeavor to really share with the industry knowledge and also some practical aspects of how we can improve within our operations within the food and food and beverage industry, for that matter. And then so I'm sure you're going to find this very interesting, this topic. It is a rather broad topic, so obviously we won't go into too much detail. But in essence, the takeaway would be that you know, there's a lot of areas that we can focus on, a lot of opportunities, and close collaboration with experts across the industry, across the industry actually globally. You know, we can manage to get best practice into the South African food and beverage industry. So the topic is really about the design criteria and factors important in achieving the optimum hygienic CRB results. And I just want to confirm again that what we're trying to achieve is no matter what we do, in essence, we want to produce food that is safe for the consumer, and hence all the processes, etc., that we need to consider. Right, so the agenda really, Peter will just share with us a bit of information on foodborne diseases from a global perspective. Diseases specifically to dairy products. We'll talk a bit about recalls, and then a concept that's becoming very interesting and very important is, especially when we look at validations and when we look at troubleshooting, is the whole concept of genome sequencing. Then we look at specifically microorganisms, and that's where the hygienic part actually comes in, is that microorganisms, the interaction on food contact surfaces, and how it affects our CRP processes, and what we need to do to ensure proper validation of such processes. Then we'll just touch on some design qualification, installation, operational and performance qualification, give you a broader overview of what that actually entails. Right, so I hand over to Peter.
Thank you, Piet. Thank you, Adele. Good morning, everyone. I'm going to get started here by talking about microbes from a global perspective, just to have a look at what it is that we are trying to fight against. So each year globally, unsafe food costs about 600 million cases of foodborne diseases. So you can see that there's this great problem where from a global perspective, there's just continuous outbreak of disease. And then additionally, around 420,000 deaths, so 420,000 people dying because of consuming unsafe food. And then the World Health Organization estimates that there are 33 million years of health lives that are lost. And that means people are either getting sick or being disabled, or they are dying due to eating unhealthy food, or unsafe food particularly. And then from an African perspective, there's an estimation that 92 million people get sick because of eating contaminated food, and 137,000 people die every year. So we can see that there's a serious problem, regardless of the fact that there's continuous improvement in food safety standards and food safety criteria around the world. And then here, it's just a study by Grace and colleagues that's showing us the global burden of disease from the dairy industry. So this is dairy products. And then this slide here is showing us the burden of disease from the global perspective. So on the x-axis here, we have different areas that were studied. We have Africa, we have the Americas, we have Eastern Mediterranean, we have Europe, and we also have Western Pacific. These are the regions that were studied on the x-axis. And in the y-axis, they're showing us number of disability adjusted life. That's, we're talking about how lives are lost or lives are compromised because of consuming unsafe food. So on the x-axis, we have two things happening. First, we have the type of microbes that are causing this loss of life or disability or disease. And then we also have the who are the people affected. So the letters B, C, D, and E are showing us who are the people affected. So B is for low mortality in children and adults. And then E, for an example, means high mortality for children and adults. So if we're looking at Africa, for an example, we see that there is high mortality for 100,000 people. This is closer to 50 percentage. And then the microbes that cause this mostly are Salmonella. You can see at the bottom. I'm not sure if you can see very clearly, but Salmonella is one of the microorganisms that's causing this disease. Next one is Mycobacterium, so tuberculosis bovis, and then can affect animals and humans. And that's the second one, the blue that you can see there. And then the third one is Campylobacter. Um, and then that's the third one in particularly in Africa. And the same applies to many other continents, as you can see here. In Americas and in Europe, the numbers are a bit lower, and that's because they're checking this often. In the United States, for an example, you'll find that government employees are within the factories, embedded within the factories, assisting the factories to make sure that they're following food safety practices. Next slide. And then, so what are some of the microorganisms that are important for for milk or dairy products? About 90% of dairy-related diseases are caused by either Staphylococcus aureus, Salmonella, Listeria, or E. coli and Campylobacter. So these are important microorganisms that we have to look out for, at least understand their behavior and know what it is that different companies can do to minimize the outbreaks of these diseases or the outbreaks of disease caused by these microorganisms. I'm going to talk about these different microorganisms as we continue, but first, I just want to highlight some cases, the outbreaks that have taken place recently. And the challenge usually when we look for this is that we don't find good data in Africa, for an example. There are studies that I was looking at from African perspective, but we don't have much data from Africa. So we generally look at data from the United States and Europe. And here I have an outbreak due to E. coli from Tennessee, a state of Tennessee, and then 5 cases and 2 infects were infected because of consuming raw milk in 3 states in a cow share arrangement. So what they do is that they would have cows that are shared, so they would move cows from one area to the next, or they would have a larger area where the cows are shared and they would distribute the milk to different companies in these different states. So the challenge here is that they are consuming raw milk, and then as I was looking at the data, I saw that consumption of raw milk is probably a greater risk factor than just pasteurized milk, even though it's possible that pasteurized milk could be contaminated. However, it's really raw milk that's causing most of these cases. And then in this case, due to the Shiga toxin producing E. coli, and then the cases are in these 3 states. We have 2 10-month-old infants who are hospitalized, and then in more than 100 participants in this milk sharing group in the states of Georgia, Tennessee, and North Carolina. So you can see that because of the sharing of raw milk, the outbreak is now in 3 different states and could be in many other states as well. Next slide. And then this is another case. Again, this relates to raw milk. You may find that many countries discourage the use of raw milk, but still many people are still consuming raw milk. Somehow people seem to think that it's a healthier option, even though we know that it's a great risk factor to consume raw milk. Here it's 5 people were sick in France, 2 very seriously, 1 in Belgium after drinking a brand of raw fermented milk. So it's the same issue here, and then this was because of the sugar toxin producing E. coli as well. So this just highlights that even though the industry are pasteurizing the milk, but there are still companies that are producing products from raw milk or raw milk itself, and then it's important that there's additional protective measures when working with raw milk. Next slide, please. So in this case, I want to show how they go about instituting a recall, food recall, and this is from the FDA. It's an excerpt from the FDA. So we have Cricket Creek Farm. They are recalling Sophilis and Tobassi cheese because of potential listeria contamination. So what they do here, this is in Williamstown, Massachusetts, and then 165 units of the cheese, 149 pounds of this cheese, because it was thought to be contaminated with listeria. And they're able to do this because they have a very good traceability methods that they're tracing well. If perhaps you've read about the Food Safety Modernization Act in the United States, so they have been increasing traceability, increasing ways to determine the source of the product, to even know who was producing it at the time and where it comes from. So they have good ways. So in these cases, you can see Sophilis product code 087055 is a washed pasteurized milk cheese with soft rind pinkish hue. So the FDA is able to access all the important information that relates to the product so that they could give it to the public, and the public is able to know precisely what to look out for. And then the product is labeled 315, 341, and 048, washed raw milk cheese, orange pinkish creamy interior. So that's the case again. They have specific code for each one of the products so that when the recall is made, both the consumers and the companies and the distributors can know precisely which products to look out for. They know the source and they have all the information. So because of the outbreak, there was one hospitalization because of listeria. And then the product was tested at the BioTrax testing laboratory, and then that's where they determined that it was positive for listeria. So here I wanted to highlight just having clear traceability, being able to label your product clearly, and then so that if there's an outbreak, you can provide that to the right authorities, and they will be able to give out the information without having to scramble and trying to find information. So because of the way in which they work in the United States, in this case, they're able to provide that information. Next slide, please. So next up, I'm going to talk about different microbes. I stated that there were some microbes that are important from the dairy perspective, and I just want to highlight these different microbes. So first up, we have the genus Salmonella. When I was highlighting in the previous slide, we saw that Salmonella was one of the three major microorganisms that are causing disease, particularly from the dairy industry. So Salmonella, it survives in the temperature of 7 to 47 degrees. So room temperature is optimum temperature for this microorganism, for this bacteria. The pH of 4 to around pH of 9 with the optimum pH of 7. And that's the physiological pH. So it can survive very well in around the pH that is a human pH and animal pH. And when one is infected with this microorganism, the symptoms will be diarrhea, abdominal pain, fever, vomiting, nausea, and death. Again, these symptoms of diarrhea, abdominal pain, you will see that many other microorganisms seem to also cause the same type of symptoms. It can survive for a long period of time, and then it has been found in chocolate that was stored for up to 18 months at room temperature. And again, because its optimum temperature is room temperature and the pH is just the physiological pH, it makes it easy for the microorganism to survive on surfaces for a very long time. And then the infective dose, and then again for Salmonella typhimurium, One cell ingested can infect a person, so that's a very low infective dose. And then for the Heidelberg in cheddar cheese, it's been around 100 to 500 from the tests that were conducted. So again, this just shows you why we need to be vigilant. And then Pete later on will talk about ways in which companies can clean surfaces and clean different areas within the your organization so that you can minimize the risk of the outbreak. Next slide. Another one is Listeria. Again, in the cases that I show, Listeria was another organism that is responsible for outbreaks in the dairy industry. And we know that we have had that Listeriosis outbreak in South Africa. So it can live in different types of environment. It's a facultative anaerobic, meaning it could survive even if there's not much oxygen. And then the temperature at which it could survive, it's minus 0.4. That means it can still survive in the refrigerator all the way to 43 degrees. And this makes it difficult to work with it, because if you refrigerate a product, the microorganism can still survive. And if the product is in ambient temperature, these microorganisms can still survive as well. And then in regard to the pH, 4.39 at 30 degrees Celsius will be an ideal pH for the organism, or 5 to 9.6 at 5 degrees Celsius. So this is, it could survive in the refrigerator in that range of pH. And then it can infect, and here we're saying it can really cause infection in healthy individuals, but from here in South Africa, we saw that there were a variety of people who got sick from ingesting this microorganism. And then it can cause stillborn or abortion. And then it causes endocarditis, meaning it could infect the lining of the heart, and it could cause inflammation in the lining of the abdomen. It could even cause what's called pink eye sometimes, and then it could inflame the brains, and it could also cause like blood poisoning. So it's a dangerous microorganism, and then it will be hard to tell that it's the microorganism that's causing you to get sick, because it could be any one of the above symptoms. It has high mortality rate, one of the highest, about 25%. And then it's estimated that 10% of the healthy adults will carry it in the gut or in the hands. So hand washing, hygienic practices are very important when dealing with both this Listeria and Salmonella as well. Next slide, please. And then another microorganism that I highlighted earlier is Escherichia coli. And then the minimum pH is 3.8, temperature from 7 to 45 degrees, meaning it can thrive at room temperature. And then it causes this gastrointestinal tract. It will live in the gastrointestinal tract of men, so and animals as well. So both men and animals are carrier. There are several species of this microorganism causing different types of symptoms, and then but collectively they are called verotoxin producing E. coli. And then not all of them are pathogenic, but most of them are pathogenic. And you know of 0157H7, which will cause hemorrhagic E. coli, and of course that's one of the most dangerous type of E. coli that could infect a person. Next slide, please. And then we have Bacillus. I just added this one. It's a mesophilic gram-positive spore-forming microorganisms. It's present in a wide variety of environment. It produces toxins, and therefore, so it's not just the microbe itself, it's the toxin that it has produced that will cause diarrheal disease. And then it could cause nausea, vomiting, and again, the toxin is heat resistant, causing this to be a challenging microbe. You are targeting the microbe, but it left the toxin, and the toxin can survive even up to 120 degrees of heat treatment, and that's just very dangerous. So toxin-producing microorganisms pose an additional challenge. Next slide, please. So I was talking about toxin producing microorganisms, that it's not just about targeting the microbes, that we are doing everything to target the microbe, it's also the toxins that the microbes are producing. So it is important that we understand that in both the cleaning, in both the type of treatment we're producing, it's possible that the toxin is back there, and it's possible that the toxins are heat stable, meaning they will resist the heat treatment, and therefore people will still get sick from perhaps pasteurized milk or pasteurized product. And this is something that's possible, and that may be because of the toxin, or the microbe itself is heat resistant. And then some of these poisoning can occur from toxins produced by Clostridium, from Staphylococcus aureus, or Bacillus, as I stated before. Next slide. And then we also have spoilage microorganisms. So previously I was just talking about pathogenic microorganisms. That's because they usually get a lot of attention, and for obvious reasons. But then for a product perspective, you also want to be aware of spoilage microorganisms. These are Pseudomonas. They are gram-positive obligative aerobic rods, and then they cause spoilage. They can thrive even in temperatures of -1.5 degrees, so meaning they can grow even in the refrigerator. They will produce these sulfides and esters that will cause off flavor or an odor in your food product. So they will be spoilage microorganisms, and they will just generally spoil your food. They're not pathogenic themselves, but you're caring about your product, and then this will spoil the product. Next slide. So what can one do? As Piet was saying previously, lately there is this whole genomic sequencing that's been used. I think it started being used widely since 2019, so it's relatively a new technology. What happens is that in this technology, we're using the genetic material of an animal, a plant, or in this case, microorganism. So we would get the genetic material, remove the genetic material from the organism, and then we would digest that the genetic material. When you digest the genetic material, you would use restrictive enzymes. Restrictive enzymes can read the genetic material and cut it at specific place. This is because the genetic material is made up of this repeated code of ATCG, and then this code it's a predictable code, it's a repeated code. So when a restrictive enzyme reads a frame of this code, of the genetic code, it cuts at a very specific area. And then when it has cut at this specific area, that means we can tell what the length of the code is, because we know the restriction enzyme that we used can only cut very specifically. Once we have these cut pieces of DNA, we can amplify them using polymerase chain. So we are using PCR to amplify or to make many, many copies of the genetic material that we have cut using restriction enzymes. From there, we read this, and then we get a sequence. And then these sequences that we get, we can read the sequence, therefore, and it will be able to tell us which microorganism is responsible for the outbreak that we are tracing. And then using this, we can also tell if there were mutations in a particular microorganism. So it can give you very specific information about which microorganism. Is it a particular variant of the microorganism? And then so you can distinguish even variants. You can tell if the microorganism that is causing a new outbreak here caused another outbreak elsewhere. So you can be able to trace even the movement of microorganisms. So this is definitely revolutionizing food safety globally. Next slide, please. So what are some of the areas that you need to look out for? And I'm just going to highlight this because I know Piet is going to talk about this in his part of the presentation. So we know that humans are carriers of microorganisms, and you saw when I was explaining the optimum area for growth for these microorganisms, it's usually pH that's very close to physiological pH. It's usually the temperature that's ideal for humans as well. So therefore, humans are carriers. They carry these microorganisms very easily in our hands. Our hands are touching our cell phones and so on. So we will be carriers of microorganisms in many cases. And then these microorganisms can grow in different surfaces in different places. They could adhere to surfaces and form biofilms. And I know previously we talked about biofilms and explained what they are. And then in processing equipment, they could colonize both on stainless steel, in plastics, on rubber, on PTFE. So they could colonize different types of areas or surfaces that are exposed. They could be distributed through aerosols in the air, in the processing environment. They could easily move in droplets of air in the processing plant. And then they would then attach to surfaces. And then when they find an environment that is conducive for growth, meaning an environment that has moisture, an environment that has a nutritious food like milk, and they will grow very quickly. Within 20 minutes, you have another generation. So, and then some of them can cause corrosion, and that's biofilm. From a biofilm perspective, they could cause corrosion on the surfaces of processing equipment. And if they are corroded, that means it's a good place for colonization of microorganisms within your processing plant. Next slide, please. So next up, I will hand over to Piet, who is going to highlight the cleaning, or what can be done with regards to cleaning in place. Piet, you can take over.
Yes, Peter, thank you. Thank you very much for that information. Obviously, it's a basis where we need to work from and consider. Ladies and gentlemen, just from a hygienic design perspective, we also did a presentation last year with the Dairy Standard Agency covering other aspects of hygienic design. But just as a recap, is that hygienic design is a holistic approach, and it covers all aspects of operations and practices within the operation. As such, very clear aspects relating to hygienic design, building design, your utilities, your processing equipment. We'll talk a bit about that in a later slide. Cleaning and sanitation. There you can see the CRP aspect is how does that work in terms of hygienic design, and then also personal hygiene. So the takeaway here is really to when we look at all of these aspects, is they do not stand in isolation, and hence when we do trouble solving, when you do validations, when you do work within the food plants, it's critical that we cover all these aspects. Right, so when we look at hygienic design in relevant to CRP, there's a number of criteria that we need to consider. The first thing is the hygienic design of the CRP installation itself. It really covers criteria of how my CRP set is designed, what are my volumes in my CRP tanks, what is the sequence of my chemicals and detergents and rinse waters that is within our CRP loop or CRP system. We then need to consider what type of instrumentation we require and where it needs to be positioned. And when we talk about that, is aspects like your supply pumps to the relevant objects that need to be cleaned, our temperature probes, our conductivity probes, flow probes, etc. So all of that equipment, the design and the layout is critical to ensure that we achieve an optimum result when we look at CRP itself. The design of the processing equipment is also very important. Obviously, when we install tanks and we install transfer lines, there are aspects that's critical that we need to consider, ensuring there's no crevices, that we do not have areas where we would have stagnant water or water accumulating, or even for that matter, product accumulating where we can't reach. And also aspects like within our piping systems, when our transfer lines, are there any areas of dead legs that we need to consider and that we need to obviously remove, because dead legs can create a lot of problems when it comes to the CIP cleaning process. In addition to that, guidelines around valves, what type of valves we need to install, what type of pumps, how do we, on pipe couplings, how do we ensure that there's no leakages, there's no contamination from elastomers and other type of material that will be used in the process. The treatment of stainless steel surfaces is very important, very critical. In our experience from CIP validations is that a lot of areas there's poor welding, and obviously that modifies the surface of the stainless steel, and then that adds additional challenges in terms of cleaning and sanitation within those areas, including obviously damages to equipment, different types of corrosions, crevices corrosion, pitting, all of those that actually then gives us challenges when we want to achieve a good microbiological result in our cleaning processes. Also the design and construction of materials for the equipment. Again, we need to have a clear understanding what is our product that we produce, what is the impact on the surface that we have, and then that all gets done via risk assessment that will give us guidelines in terms of how to mitigate those type of risks. So when you look at other factors that will play an important role when we talk about CIP design and we talk about CIP cleaning results, is our soiling and our soil composition. A lot of times, the understanding of what happens to soil, especially when you start applying heat, that gives us bigger challenges in terms of when we do cleaning and disinfection, and soil composition, because the critical part of that is that determines what type of detergent or we will use to actually remove that type of soiling from the surfaces. Right, so there's an interrelationship between, and I know in some places in the industry people use this terminology quite broad. I think this gives us quite a good understanding, and this is directly from the EHEADS guidelines on validation of cleaning within the food industry. So the key criteria is about validation. That's probably the best way to explain it is, does it work? That's why we do validations, is we try to establish if it's working. We do verification. So once we've done the validation, we've implemented what needs to be implemented. We verify that actually works. And then also linked to that is obviously the monitoring of the different variables during, for example, a CIP cleaning process. So these go hand in hand, and I'll just say a bit about them, these aspects separately. So what is validation? So it demonstrates that the cleaning procedure is effective to produce a certain level of cleanliness whilst applying expected worst case conditions. That to me is the important part. The worst case condition is that when you have an application where there's low soil, little heat, then the cleaning program will obviously take into account that to get us a microbiological clean result. However, because we need to use worst case scenario, obviously that won't work in areas where those parameters have actually changed. So very importantly, you cater for the worst case condition, and that gives you an assurance that anything less than that, the cleaning program would be effective. So once it's validated and it's applied, then obviously it needs to be verified and monitored. So we in essence have three types of validations. The first one is being prospective. Okay, it's really starting from scratch, understanding what needs to be cleaned, looking at worst case scenario, and conducting a validation. Then the concurrent validation is where it's obviously practical to do it, the validation separate, so you would do it concurrently. And then retrospective, and I think within the South African market, we had at that stage where traditionally we have a lot of methodologies around CRPs and CRP cleaning, and it's really about having data available that gives you an opportunity. The retrospective validation really gives you an opportunity to improve the CRP in terms of efficacy and in terms of efficiency. So again, if we want to do a CRP program as efficient as possible, and they need to be effective. And our experience within the industry is that once you can optimize on both those sides, that is where you get optimization in terms of costs, which obviously today is quite critical. And also, not just that, from an environmental perspective, when we look at water and energy savings. So all of these aspects gives us a good opportunity to validate our current scenarios, identify shortcomings, and then implement what we believe need to happen, obviously through a process of verification and controls, etc. So when it's just brief, if we look at verification as it works, okay, occurs during after the cleaning procedure through various activities that we observe, documents that we review, records that we review, etc. And then on the monitoring side, again, we have a lot of data available to ourselves. We can monitor, we set parameters, we have instrumentation that can measure specific data, and then we can also, from all of that, conclude and put together some form of remedial action, if not opportunities for optimization. And then the key thing, it's real-time measurement, so we need to understand what's happening at the time of, for example, a CRP cycle within our operation. So when you look at CRP programs or protocols, it's really about different cleaning steps, the object which need to be cleaned, critical there, what's the physical layout, what's the size, number of circuits, all that we need to consider. That's on the object side. On the process side, we need to understand, is there any heating involved? We're talking about storage, UHT, evaporation. All of those will obviously give us a different view in terms of how we need to CRP those items. I've mentioned the properties of the soil. What we find also in a number of instances, obviously, is that the removal of soil becomes very important, because we talk about microorganisms, and Peter has given us just a bit of background on that. The key critical aspect there is we need to get surfaces microbiologically clean and soil removed to that level, because obviously that gives breeding ground for microorganisms. When you look at the CRP validation, I alluded to that earlier. You've got the design qualification, you have the installation qualification, you have operational, and you have performance. And what we'll do, I'll just introduce you to each one of those. Obviously, it's a very broad and detailed subject at each of these levels, but just to give you a sequence of how we would typically validate a CRP system or CRP processes. But when you look at the process and the machine description, obviously we need to look at the CRP set, we need to look at the cleaning agents being used, on the process control. Important, as we said, what happens in the process, where is heat applied, when is temperature, what time is allocated, what happens with the product flow, what pressures does it operate at. So a whole host of parameters from the processing specific part of the operation. I just highlighted two things here, the CRP supply pump and return pump. Critical list criteria that we need to consider when we look at these pumps on the CRP side, because it does a couple of things. Obviously, it supplies cleaning detergent to your object being cleaned. In the process, we need to ensure that based on pipe diameters, etc., we need to ensure that we get the correct flow, as CRP is all about flow, because we do depend on flow to give us the mechanical action to remove soiling. So the supply pump capacity, important. The CRP return pump capacity, obviously also important, because if there's some deviation in terms of standards that we need to apply, obviously we get a compromised cleaning result due to what we call pooling. We don't get adequate coverage in tank surfaces. So very important aspect. And then the nozzles itself, when you look at cleaning of tanks, are we getting correct spray patterns? Are we getting correct pressure? These are all aspects from a design perspective that we need to consider, and because that forms part of the validation. So if there's a shortcoming in design, there's nothing you can do to mitigate it in totality. Hence, the design needs to be correct. When you look at the installation, again, you would look at the capability of the nozzles as it relates to flow and pressure, the placement of the nozzles within tanks. There are a number of mathematical formulas that one would use to consider the number of nozzles you require in a tank, what the positioning should be. When you look at dead ends, I mentioned that earlier, dead ends in piping, that is very, very critical. And in my experience, well, in our experience in the industry, is it's not always that visible to actually identify dead ends. And as such, you need to have some expert eye to get to identify those areas. Capacities, obviously, within the tanks, in the CRP tanks, very important. Obviously, you don't want tanks to run dry during CRP process, and there's all other parameters that one need to consider to ensure that the capacity does not become restrictive in terms of what you're trying to achieve. The water source, obviously critical, because you're cleaning with 90% plus of your detergent comes from water. So very critical that you need to understand not just the chemistry, but also the microbiology around the water being used for CIP. And then obviously your chemicals and disinfectants. So operational qualification, this is now performed during the CIP run. And the prerequisite is that one would have completed the installation qualification. Any shortcomings would have had to be addressed to ensure that that is resolved. And then this will actually imply a practical testing of various aspects of the CIP process. So you'll do a verification of the CIP at the startup. It's good practice after a certain number of batches being manufactured to verify the performance with all its criteria, and also in terms of the process or the instructions. Talk about works instructions is the educational part of operators to ensure that the CIP is conducted in accordance with the standard operating procedures. And then verification of the procedures is to verify that the CIP was performed in the right way. Obviously, there will be data from PLCs and SCADA systems that will give us some indication. There is technology that allows you to do these measurements separate to the actual PLC and SCADA systems. So you would run some measurements outside of the PLC as a separate entity. And what that helps you is to look at your phase during CIP. We talk about phase management, and it's really optimizing the times during rinses, during cleaning, during disinfection, again to link us back to the aspect of efficacy and efficiency. Right, so just the purpose of the performance qualification then is to verify that the process will consistently produce acceptable products under normal operating conditions. So very clear, whatever we've validated, we've implemented, we need to ensure that every time that there will be a CIP conducted, that the result that we achieve will be the same every time we do the CIP. So very important aspect, parameters relates to flow, pressures, temperatures, times that we need to ensure that is in line. Training is a very important part. In our experience in CIPs is that a number of times you would get still some water and even product residue remaining in the systems. And then the process itself, verification of CIP, did not reveal potential hazards, because obviously we would have done a hazard analysis prior to the whole validation process. And that will be our parameters in terms of our end goal. Right, that is, as I say, CIP is a very detailed topic to discuss, which we can't do in an hour. But I hope that I've given you some overview in terms of how we should go about doing validations. Just one or two things just on our organization. EH, the European Hygienic Engineering and Design Group. As Adele indicated, I'm the chair for South Africa, and here's just a graph about our activities. But the important part is we make use of subject matter experts across the globe to actually deliver guidelines. So everything that I'm talking about in this presentation, there are guidelines that can guide us as an industry in terms of how to achieve optimum results. So should you wish to participate or become a contributor to such guidelines and detail that we gather for the industry, please feel free to reach out to me at any stage, either myself or Anne Wallace. Yes, just a breakdown of advanced training that we programs that we do in South Africa, and the globe. There's just some detail about our websites, and then there's some contact detail for the regional section, South Africa. So should you wish to communicate with us. Adele, thank you very much.
Thank you so much, Piet and Peter. I really do appreciate that. Can I ask the audience if there's any questions, if you can please make sure to add the questions into the question bar. I think, Piet, something that I always say is that, the basics must be in place. And like you've explained now, a lot of money is spent on chemicals and cleaning and all of that. And we have to make sure that those processes and everything that we put in place is working. Piet, if I may ask, what are the concepts of efficacy and efficiency as it related to CIP applications?
Yes, Adele. So from an efficiency perspective, is that we want to get a cleaning result as efficient as possible. In other words, we would ensure that we've optimized the time to, and I'm taking just an example, the time to clean an object, the amount of energy that we need to input to get to that cleaning result, and then also the amount of, or the concentration of detergents that we, or chemicals that we would use to get that result. So in other words, it's really about cost, and all of those relate to costs, because you need to save cost. You don't want to waste. So just on the efficiency, and then efficacy is obviously very closely related, but it is really about how effective it is to clean. You might not be in a position to change some of the parameters, or that will impact cost, but still, what is the best methodology to clean a pasteurizer? I'm just taking it as an example.
Okay, yeah, thank you for that. I think in terms of acronyms and words, and like you said, often words are misused. I really think that your explanation of validation, verification, and monitoring was done very clearly to assist people not to get confused with those words. And then the typical approach to CIP validation. Can you just reiterate again those 4 concepts that you spoke about?
Yeah, so what's the whole concept about is we need to look at, you need to start a base. As I said, it doesn't help if the installation is not adequate. So you need to do the installation qualification. You need to look at the process, qualify the process, because in all of those things there might be hidden aspects that's not considered. My experience, I've been in this industry for 36 years plus, is that what one tends to do in CIP is to try and make a chemical solution to all these issues. So and obviously that has a cost impact. So it's really to start from the basis, look at the design, look at the operational, and follow that logical process, because at the end of the day, that will give you the solution that you require.
Absolutely, thank you for that. Peter, thank you so much for your presentation and your information. It's already 11 o'clock, so we've run out of time for any further questions. If there are any further questions, please email them to me and I will make sure that I send it on to Piet and Peter to get their answers. This was the fourth session for the year from the DSA sponsoring these webinars. If you've missed any of the previous webinars, please visit our website, foodfocus.co.za. And at the top of the page, you will see there is a tab that says resources. If you hover over the link, it will bring up a tab webinars, and the recordings of the previous webinars are listed on this page. Please also, if you would be so kind, just to answer a short survey after the webinar is closed, we will appreciate that. And then the DSA's next webinar will be in July, around about the 26th of July. We will make sure to make you aware in our newsletters and on social media. And with that, Piet and Peter, thank you so much for your time and thank you for your input. And I would like to wish everybody online a pleasant day further until the next time. Thank you so much. Good day, Piet.
Thank you, Adele.
Thank you. Bye-bye.
Thank you. Thank Peter. Bye-bye.